All right, everybody, grab your hard hats and welcome to the High-Rise Exam Construction Workshop. I am your chief architect for today's explainer, and we are diving straight into the deep end. We are laying down the schematic layout for an absolute heavy hitter on the Cambridge AS and A-Level Mathematics 9709 paper, Iterative Methods. Specifically, we're talking about mastering the load-bearing formula, x sub n plus 1 equals f of x sub n. Now, if you are tuning in, I know you already have a solid grasp of the underlying algebra. You know how to clear the site and pour the concrete. But honestly, knowing the math and actually scoring full marks on the final examiner inspection, those are two completely different things. To help us out today, I've brought along two of our junior builders. First, we have Alex. Now, Alex is a hard worker, but Alex tends to stack way too many unorganized factual bricks, just throwing numbers everywhere on the page without a solid logical foundation. And then we have Sam. Sam is all about that flashy exterior design, making the paper look incredibly neat, but completely forgetting the load-bearing sentence structures required by the examiner. Today, we're going to fix both of their approaches and yours by building an unshakable mathematical foundation.
So, you might be wondering, why do these academic buildings collapse? Why do students lose easy marks on iterative methods? It is a truly frustrating reality on the exam site. Year after year, the principal examiner reports show that students who clearly understand the core equations still bleed points on these high-tariff questions. Alex knows exactly how to punch the numbers into the calculator, Sam knows how to find the root, but when the final grade comes back, they have both missed out on crucial method marks. Why does this actually happen? Well, it is because they are ignoring the structural integrity of their answers. They treat the exam like a simple math quiz rather than a rigorous engineering project that requires a clear, step-by-step demonstration of proof.
Listen to this direct quote from the site inspectors themselves. As the principal examiner reports highlight, most students lose easy marks. But I am going to show you exactly what examiners look for. This isn't just about getting the final numerical answer right. It is about proving your logical construction process to the examiner in a very specific, undeniable way. We have the ultimate architectural blueprint straight from Cambridge, and by the end of this workshop, you will have the exact playbook you need to secure every single point available to you. No more dropped marks, no more collapsed equations.
Here is our schematic layout for today. First, we will cover the core theoretical principles. Second, the technical exam methodology. And third, the top examiner warnings. Let's move right into Section 1, Core Theoretical Principles. Okay, it is time for stress testing the framework. I want you to imagine a digital grid overlaying your exam paper. Right in the center is the core architectural formula for iterative methods. X sub n plus 1 equals f of x sub n. Alex looks at this and thinks it is just a single brick to toss into a pile, but it's not. What is absolutely crucial here is that this formula rests on precise causal relationships. It is a dynamic loop. It is the elevator shaft of your entire building, where the output of one floor's calculation becomes the direct input for the next floor up. Think of solving an equation like x cubed minus x minus 1 equals 0. When you rearrange that into an iterative formula, the examiners are checking to see if you understand the structural flow of that specific chain, not just that you can mechanically process a list of decimals. Let's look at the assessment objectives. You are being tested on three main pillars: knowledge, application, and analysis, or as we call them on site, assessment objectives 1, 2, and 3. Right now, Alex and Sam are debating how to balance these objectives so their text blocks survive rigorous marker reviews. The truth is, the assessment framework heavily prioritizes analytical depth over superficial breadth. The examiners aren't just checking if you've memorized the basic formula. They want to see your load-bearing logic. They're testing your ability to deeply analyze the behavior of the iteration itself. Does it converge? Does it diverge? You have to demonstrate that you understand why the structure behaves the way it does.
And this brings us to a major strategy for scoring top-tier marks: cross-topic connections. According to examiner reports, linking topics equals significantly higher marks. What does that mean for your building? It means the conceptual framework for iterative methods doesn't just stand alone in an empty lot. It draws on established principles from other areas of your math syllabus. When you can explicitly weld your iterative working to coordinate geometry or tie it directly to your calculus skills, you are demonstrating the exact kind of systematic analysis and evidence-based reasoning that examiners reward heavily. You are showing them the whole city grid, not just a single building.
All right, moving on to Section 2, Technical Exam Methodology. Let's look at the practical execution.
This is your 5-step procedural sequence. Step 1, deconstruct the question. Step 2, extract the relevant data. Step 3, select the framework. Step 4, execute with clear notation. Step 5, present with correct terminology. While deconstructing the question and extracting data are vital for pouring the foundation, I want you to focus heavily on steps 4 and 5 here. The examiners award marks for the construction process itself. If your execution lacks clear notation, or if you use the wrong terminology to describe your steps, your building fails inspection. You will lose method marks entirely, even if your final iterated value sitting on the roof is perfectly correct.
Site inspection. Okay, everybody, put your calculators down for a second. To fortify your academic foundations and get weekly structural grade upgrades, you need to subscribe to Ace the Exams right now and turn on all notifications. Seriously, hit that button so you don't miss our next workshop. Okay, let's resume. Right here is where our builders, Alex and Sam, just hit a massive, unexpected structural crack mid-paragraph. Examiners are incredibly strict regarding presentation conventions. You must use proper headings, correct terminology, appropriate formats, and clear annotation. So how do we fix this crack? I am stepping in with the Peel matrix to flawlessly weld your evidence to your analysis. Peel stands for Point, Evidence, Evaluation, Link. Point, state the iterative formula. Evidence, show your first substitution clearly. Evaluation, present your sequence of values properly formatted. Link, state the final route to the requested decimal places. Strict adherence to this matrix is absolutely non-negotiable for the examiner.
Let's head into our final section, Section 3, Top Examiner Warnings. This is the insider edge.
All right, it is time for our live audience diagnostics. We are going to run an interactive viewer's stress test right now. First, let's look at the top 3 mistakes that cause a total structural collapse straight from the principal examiner reports. Number 1, forgetting proper format. Number 2, not checking your format and presentation. And number 3, providing answers that are not specific to the context given. It is staggering how heavily formatting and context weigh on the final score. So, for test number 1, I want you to imagine a 60-second visual countdown timer on the clock. You're looking at a complex blueprint graph of an iterative sequence. Can you extract the primary metric? Is it a cobweb diagram or a staircase diagram? If you can't visualize the formatting difference in your head before the clock runs out, your foundation is at risk. Let's move to test number 2, identify the flaw. I want you to compare these two approaches, generic mathematical answers versus scenario-specific, context-linked answers. Higher-order assessment objectives demand real evaluation. If a question asks about the limitations of an iterative model, Alex usually just writes down a generic textbook fact, total structural failure. A top-scoring, evaluative answer from a master builder will consider the specific evidence, identify the exact assumptions made in the given scenario, and explain how alternative interpretations affect the final structural load. The absolute classic mistake students make is giving a generic answer to a highly specific scenario. Can you identify the flaw in your own past papers?
The crucial takeaway, the ultimate weld that holds everything together, is this. Always link your reasoning to the given scenario. Identifying limitations and assumptions means absolutely nothing in a vacuum if it isn't explicitly linked to the specific context of the question. Top-scoring candidates justify their decisions with evidence from the exact text they are given. They stress-test assumptions based on the actual word problem sitting right in front of them. Never, ever write a generic statement when a context-linked statement is what's required to pass the final build inspection.
Let's keep this interactive stress test going with a memory hack to lock this terminology into your brain. Can you create a mnemonic using the first letters of our key terms today? Format, context, notation, terminology, FCNT. Creating your own mnemonic is an amazing way to ensure active participation and retention. Maybe something like, focus carefully, note terminology. Take a second when this workshop is over to write one down. It might just be the safety harness that triggers your memory in the middle of a high-pressure, high-stakes exam situation.
All right, team, it's time for the final build inspection. Let's recap the core takeaways and the 3 rules of sentence engineering we learned today. Rule 1, master the theory and the causal relationships of the formula. Rule 2, follow the strict 5-step procedural framework using the Peel matrix to secure your method marks. And Rule 3, always link your evaluation to the specific context of the question. Sam and Alex finally get it. They just read their completed, flawless response paragraph, and the structure is completely solid. Applying this precise playbook is your key to mastering iterative methods.
I will leave you with this final provocative question to think about before we close the site. How will you adjust your presentation format on your next pass paper? Will you continue to just scribble unorganized numbers in the margins like Alex used to? Or will you treat your exam like a professional, analytical blueprint that demands correct terminology and clear, load-bearing annotation?
The choice is entirely yours, but only one approach gets you those full marks. Take a moment to really think about that. Thank you so much for joining me on this explainer. Before you go, make sure to subscribe to Ace the Exams, click that notification bell, and leave a comment down below with your specific subject and level. Apply these examiner insights to your next practice paper, and I will see you on the next build.